Well, hello everyone. I'm here in the Techno Cafe at the virtual ISTH Congress, and I'm pleased to say I've just come across my friend and colleague Stephen MacDonald. Hi, Stephen.
Hello, Gary. How are you?
Okay, fine, thank you. Stephen is the principal clinical scientist in the specialist Hemostasis Lab at Adam Brooks Hospital in Cambridge in the UK. And Steve, I'm glad I've come across you because Technoclone are actually doing a video from our little section on the ISTH website about manufacturers and customers. And as head of one of the leading specialist hemostasis labs in the UK, I'd rather like to pick your brains on the matter. Is that okay?
Absolutely.
Yeah.
Carry on, please do.
Well, first of all, what do you look for in a manufacturer who supplies you with diagnostic hemostasis products? What do you want from them as the customer?
Well, yeah, that's a good question. What do I want? Am I too demanding? Perhaps I may well be. We start off with very simple things. We want reliability. When you have a manufacturer, you want to have an agreement in place that they will provide you with things, and those agreements will be kept to. So that's extremely important. And also that if there are any issues, they're very reactive to that. And if you contact a company with a potential problem, then they listen to the problem and they will know the appropriate course of action to take. What do we look for in general from a manufacturer? It depends what we're looking for. It depends what we're asking for. If we're looking for reagents, analyzers, or combinations of the both of the two, we will look for different things. But again, reliability of machines, uptime. We have a very busy schedule these days in laboratories and specialist labs and in larger blood sciences labs. So we need machines that are going to be up for a long time, that aren't going to fail, and that we can really use the walk-away technology as much as possible. Because yes, it's nice to have the big fancy robots, but we don't want to be standing in front of them all day, either fixing them or watch them going through. We've got a lot of other things to do. So other things on that sort of topic, really, environments are changing now. Laboratories are getting bigger. A lot of laboratories are combining, and that's often in the context of buildings not getting bigger. So we need to fit more into smaller spaces, and that includes more samples, more people to do those samples, and more analyzers to fit those samples. So footprints of analyzers is extremely important. Certainly in my time, we've progressed very far in getting smaller analyzers into the laboratory, and we have benchtop analyzers, which are extremely useful because then that gives us lots of storage for all our stuff under the benches that we need to have. So yeah, I mean, footprint of analyzers, reliability of analyzers. Generally, the most important thing I want from, or I would like from a manufacturer, is communication. Things are going to go wrong. That's life. We accept that. We're used to that. We always have that happening. We like to be made aware of potential issues before they hit us. We also like to be able to approach them and say, look, we are seeing an issue. Is this happening in the general field? Have you had any feedback from other customers that this is an issue? And we like them to be open about that. And as I say, we're not judging companies by having issues, because companies are the same as laboratories. There will be issues. Really, what the important thing is how they react to that, and how they respond to those things is really an important thing.
Okay, that's it. Okay, so let's say you've found a company that will do all those things for you, and you're looking for a new reagent to replace the one you're used to using for whatever assay it is. What would make you choose one reagent over another?
First things first, I want all the information to hand first before I start making these decisions, and manufacturers and companies now are very much better at being proactive at providing information. We've always had information on things like imprecision and expected performance values, but the way of the world now, we need to know a little bit more, and we want to know a little bit more. We want to know how that data was derived, because fundamentally we need to determine whether we can replicate those standards within our laboratory. And that's the key, really, when we're choosing a reagent. We need to be able to choose reagents that can hit performance metrics that are appropriate for our clinical utility of the assay. So we need to know that results are repeatable and reproducible, that there's continuity across lot numbers. We need to know that if we're quality controlling them, that the quality control material is commutable to patient results. We need to know that actually it's appropriate so that we are controlling it properly. If they're calibrated assays or if anything like that, we need to know that they're traceable. Not just that they're traceable, but we need to know what they're traceable to and how that traceability was determined. So is it an international standard? Is it a WHO standard? Is it a plasma calibrator standard, which is traceable to international standards? Because we need to know, I'll mention measurement uncertainty for the first time, probably not the last, but we need to know how that uncertainty associated with the traceability of our assays propagates to our results. And equally that goes with all sorts of different issues that we need to know how they apply. If they're calibrated assays, we need to know what the calibration process is, what the regularity of the process is, the stability, whether there's any calibration drift that's associated with that. Can we store the calibrations? Is it appropriate to store the calibrations? What's the evidence for that? Again, that's really important for us, because particularly in hemostasis, we do a lot of calibrated assays. A lot of our assays, as you well know, Gary, are indirect assays. We're not measuring directly what we're wanting to be measured. We're indirectly measuring the impact of our analyte within the assay. So we need to know that calibration is stable, there's no drift. I personally like to know how the calibration curve is modeled and on what basis that model is used, and how appropriate that is for balancing the Bayes variance trade-off that you get with overfitting calibration curves. So I'm quite demanding. I want to know quite a lot in about a reagent.
That's good. You be as demanding if you want. That's how we like it. Now,
so just one more thing with the reagents, really. I mean, stability of reagents is another thing. It's stability on board as well, because the changing face of laboratory medicine now with 24-hour services, which are ubiquitous now, long-term stability of reagents and performance of reagents over a period of time is very important as well.
Okay, well, you can get the best reagent on the market, but its performance is going to be limited by the quality of the analytical platform you're using. So what are you looking for, or what would you look for in a new hemostasis analyzer if you're going to replace one that you have at the moment?
Yeah, probably not for the first time. I'll answer with it depends. Because I mean, obviously the requirements for hemostasis analyzer very much are site dependent and obviously workflow dependent as well. So there's things that are very much emphasized by manufacturers and have been very well optimized by manufacturers, such as workload and throughput, which is extremely important. I mean, going back to the days gone by, Gary, you'll remember the water baths and our own little manual clotting techniques with ball bearings and the like. And that was entirely appropriate for the workload that we had back then, but you can't churn out 1,500, 2,000, 3,000 coagulation screens in that way. So obviously throughput with minimal input from the scientist or from the person running the analyzer, again, as I mentioned before, walk-away technology, very useful. But that's very much for the high throughput assays. And generally across a hemostasis analyzer, we have accreditation requirements that we have to be able to adhere to. So things like linking to list systems and closed processes for adding barcodes onto samples into the analyzer, so they can't be tampered with or misread or anything once the samples are read, so we know that there's continuity of results coming off the analyzer. Personally, what am I looking for a hemostasis analyzer in a specialist centre? I want to be able to tinker with things. And that's really quite important to me. I have absolutely appreciation that we have CE marking and IVD regulations that the manufacturers have to comply with in order to get their assays onto the market, and that is very good for us from an accreditation perspective, because we know that it's been through a rigorous regulatory process to get where it is on the market. But hemostasis doesn't stand still. And even just now, I've got half a dozen assays in the pipeline that, with varying degrees of urgency, sometimes mean we have to build it from the ground up, and sometimes we just need to modify an existing assay. So it's really important to me that manufacturers are open to us being able to do that, to provide the assays that we need for clinical care in the patients that we see. It is extremely important, I think.
Okay, well, you've got the reagent that you're happy with, you've got the analyzer that you're happy with, but on a day-to-day basis, we've got to make sure that they're both working together. And obviously we do that with IQC. So as a customer, what do you need from a manufacturer to help you have the best IQC package you can have?
Well, IQC is a big favorite topic of mine, as you well know. So, I mean, in an ideal world, what do we need from an IQC? What do we need? We need a material that's commutable to patient results, and that's essential. And there's certain essential requirements that we'll have for IQC, and then maybe some of the desirable stuff we'll come to later. But we need it to be consistent. We need the matrix to be appropriate for what we're testing. And in hemostasis analyzers, we're used to using lyophilized reagents, and we take it as read that the matrix is appropriate for commutability to patient samples. But again, I want to see the evidence for that. I want to see how that's been determined. In an ideal world, and this is entirely impractical, but I'll throw it out there for people watching, we need to be QCing our assays at clinical decision points and points where clinical interventions are happening, be that with initial diagnosis of a patient or escalation of therapy or de-escalation of therapy. So when we have multi-parameter QC, we're trying to assay 2, 3, 4, sometimes a dozen tests using a single quality control material. It's extremely difficult to quality control each individual measurand at the point that we want it to. And I'm not really sure how we tackle that without having 30 different quality controls, which is entirely inappropriate, and manufacturers will hang me for saying. I mean, it's just not practical. So, I mean, really what we would like in an ideal world as a minimum is we need to have pathological and normal level quality control, and that pathological level has to be something that's meaningful. So we've had issues we've heard from other people as well, where pathological QC is actually within the normal range of an assay. And that doesn't really fit the bill for what we need to do, because we need to be able to assure ourselves with objective evidence, as we are often told, that we need to know at what levels we're QCing things. QC's got to be user-friendly. It's got to be simple. Again, if you have a multi-parameter quality control that's going on an analyzer, you need to be able to select the quality control you want to run, and you want to select the quality control that you don't run. You don't want to be running everything all day, every day, because it costs a fortune and you end up with loads and loads of false alarms. So it needs to be user definable. And I suppose from a manufacturer perspective, we would look for support in being able for us in the laboratory to design our own quality control processes. We're not asking the manufacturers to tell us if we need to use rules, what rules they are, how frequent we need to be testing things. We could do with a guide, but we need to be doing that locally. And again, a part of the interaction with a manufacturer is what's common practice within other users of the techniques, because if you're the first time user of an analyzer but has been embedded in other specialist centres for 10 years, it's useful to get a leg up and just know what's somebody doing over there.
Mm-hmm.
Yeah, that's all I ask for in quality control. I'm sure there's more that will come back to me.
Well, I'm glad actually you mentioned earlier that you're looking at a number of new assays at the moment. And of course, you do have a bit of a reputation as an expert in evaluation and validation. And I happen to know that you have recently been having a look at our new Technoclone Adams 13 and Factor 13 activity assays on the Sevron S100. How have the assays performed, and how did you find the analyzer, from a user-friendly point of view?
Yeah, indeed, you're right. We have had it, and we had it for quite a while, and we did a very extensive evaluation. As you know, I'm sure I've got a keen interest in Adams 13 assays, and obviously that was the primary driver that we had. Obviously, we used the ELISA for many years, which is a fantastic assay, an excellent assay, but our service runs 24/7. So we wanted to look at fast, rapid results that can drive what is a very important clinical intervention, which is directly related to clinical outcome in patients. So the Sevron S100 automated Adams 13 was an obvious choice to have a look at, and it worked very well. And I was very pleased with it. The Sevron is a remarkably simple machine to use. It has got a small footprint, which I mentioned earlier was important. It's a benchtop analyzer. It's got a reagent carousel and sample carousel embedded in one area. Very simple, good reagents, and we have experience of using Technoclone reagents for many years, so we know what we get. Calibration, very straightforward. Calibration looked probably as entirely as I would have expected it to. Calibration looks stable, and the performance clinically in a method comparison study, comparing it to the ELISA, and also with our patients who we know have been clinically diagnosed with TTP historically, was very good. It was very high. So it's a real good option out there in the market now for what is a very in-demand assay for people at the moment, because I'm sure you're aware that there's the tender going out now for specialist TTP centres, so the requirements from the laboratory to provide services both locally and as a network laboratory regionally is going to ramp up. So what we have to provide as a potential user as in a specialist centre, we need a quick, reliable walk-away technology that gives us an answer that we can understand and that we can relay to our patients as quickly as possible. So I was very impressed. I thought it was a very good machine.
Okay, that's fantastic to hear. Thank you for that. What I will say to you and the listeners is do have a listen to our product theatre, because we've got some interesting new developments in Adams 13 inhibitor testing using the Technoclone assay. So watch out for the product theatre.
I'll be looking for that.
One last question, and be honest, a little bit of market research on our part. What do diagnostic labs need at the moment that you're not currently getting or aren't widely available from the diagnostic hemostasis manufacturers that are out there? What do you need from us you haven't got yet?
I don't know if there's anything that we don't get. I think there's things that we could get more of.
Okay.
And I think linking back again to the traceability and the calibration and things like that, the information of how quality control ranges that are represented in quality control inserts, for example, how they're derived. I think we're getting a lot more granular with our interest in the data generation process from a manufacturer perspective. I think that's because we have to be. I think it's right that we are, and I think now that we're being asked to do that, I think that's a good thing. But I think maybe we need to understand as well, and we have to be realistic with our manufacturer and supplier colleagues in that there is a lot of proprietary information and things like that in there as well. So it's striking that balance. One more thing I think, which is really key for laboratories now, is reducing the burden of what some people might consider to be the extra testing that have now been put onto us as part of accreditation requirements. So I'm thinking of the likes of region acceptance testing and things like that. And to be honest, I mean, we've always done that in our lab, particularly for prothrombin time and APTT. Hemostasis, I think, is maybe a little bit ahead of the game on the region acceptance testing side of things, because we were aware of the dangers and the perils of having a wrong MMPT or a wrong ISI for an INR.
Yeah.
But I think when you've got a laboratory that has a really large repertoire, and that repertoire has common reagents between different assays, it can sometimes be a Herculean task to do appropriate or extensive reagent acceptance testing. So, I mean, I'll use a hemostasis example. For example, if you have an EPTT-based one-stage factor assay, for example, you have multiple different components of that assay. You will quality control it with your QC. You will have a calibrator that could potentially change. You'll have a deficient plasma that could potentially change, and you'll have an APTT reagent which will potentially change. Now, if those changes aren't synced, you spend your entire life accepting reagents that you're not having time to actually run patient samples on, it feels like. Because 1 month you'll be doing the calibrator, the next month you'll be doing the deficient plasma, the next month you'll be doing the APTT reagent, and then everything else. So production processes are something that we don't have any control over in the lab, and I appreciate that the people that speak to me from suppliers from all of the companies have very little input with respect to production processes, but these are the real pain points that we're feeling in the lab just now. And somehow harmonizing reagents to have longer expiries on an individual lot number, so we have to acceptance test them less, and maybe trying to coordinate them in the same way. I don't know whether that's feasible or not. I will say that there are companies now which on an international scale will have pools of reagents which are sent to certain areas, geographic regions, so that the constant turnover of lot numbers is reduced somewhat, and that works extremely well. But that, I think that's really the pain point that I feel just now, is that we have an awful lot of acceptance testing to do. And it's not difficult. You do it on walkaway technology, and it's on robotic analyzers now, but there's still data and there's still processes you have to follow, and there's still analysis and reports and sign-offs you have to do. So yeah, that would be my thing that I would wish for the diagnostic companies to help us out with moving forward.
Stephen, I'm so pleased I found you in the cafe. Thanks for coming along. Your insights really valuable, really helpful. Thank you very much for that, and have a good conference. Thanks very much.
You're more than welcome. Anytime, Gary. I'll speak to you soon.